Hello, Algebra Honors. We're going to have our 6th day of Unit 8. Our Unit 8 is quadratics, but actually this particular set of notes is really our Unit 9, which is direct and inverse variation. So this is going to be the only set of notes that we have on direct and inverse variation. And so that's why it says right here, the following packet covers Unit 9 on variation. So we're just kind of tacking in it at the very end of Unit 8. All right, so direct and inverse variation. We're going to think about variation as being a specific relationship between ordered pairs. Okay, and so we have two different relationships we can have. We can have direct or inverse. If we have a direct relationship, there is a constant ratio between our y and our x. Our y divided by x, if we're looking at a set of ordered pairs or something, y divided by x is always going to give us the same ratio. Okay, if we have an inverse variation, though, we are going to always have a constant product. So anytime we look at any ordered pairs, if we multiply x and y together, it's going to be the same thing. So we'll have some examples and we'll show you, but I've also included in Schoology a couple of videos that have other teachers going through and explaining this as well. Okay, so direct variation, if I am looking at a table of x and y, or if I'm looking at a set of ordered pairs, I'm going to always get the same ratio when I say y divided by x. If I'm looking at a table or a set of ordered pairs and I get the same product every time when I multiply an x times a y, then I have an inverse variation. And we're going to be able to see some differences when we graph those out. And when we use these variations, we might use direct variation in situations where as one variable increases, the other also increases. Okay, and we're going to have a way to predict what we're going to have as we increase one variable, what the second variable will be. So as one increases, so does the other, and we'll be able to look at ratios to see how much. If we're looking at inverse variations, though, we are going to have the opposite thing happen. So as one of the variables increases, oh my gosh, I cannot write, increases, the other variable decreases. Okay, so direct, as one variable increases, the other increases, and inverse, as one increases, the other variable decreases. So we can think about the ratio. The ratio, I'm going to just work with direct for a minute. The ratio for a direct variation is going to be y divided by x, is always the same anytime you're looking at ordered pairs. Okay, there's an equation for that, though. We are going to say that y equals some number k times x. So it could be y equals 3x, it could be y equals pi x, it can be y equals negative 6x. It can actually even be a fraction, y equals 1/2 x. It doesn't matter, it's just going to be some constant. So we would have called that slope back in the day when we were talking about y equals mx, right? Or y equals mx plus b, but in this case our b is going to be 0. Okay, now, if I want to think about inverse variation, remember one variable is increasing and the other is decreasing. So that equation is going to be y equals k over x. All right, so, or it equals k times 1 over x if you want to think about it that way. We can also say that's k times 1 over x is the same thing, right? So some examples here, I could have y equals 3 over x, right? I can have y equals negative 2 over x. I can have y equals negative 1 over 4x. That's fine too. My x is going to be in the denominator. Okay, so as I increase my x, you can imagine that I am decreasing the y. All right, and of course I've got some more examples here. If I'm looking at direct variation, remember I have y equals kx. In this case, k is 4. In this case, k is 3/4. Okay. An example in words would be, it costs $17 for 5 cases of soda. How much does 23 cases cost? Okay, and so I can think about the fact that I know that as I increase my number of cases from 5 to 23, you know I'm going to increase my number of dollars from 17 to something, right? And we could figure that out if we wanted to, because y equals kx. So I could find k. All right, over here it takes, I have some other examples. So this is inverse variation, so I have y equals 5 over x, or I have y equals negative 3 over x. And so it takes 5 people 6 hours to do a job. So how long would it take 12 people to do that? All right, so how do we test for either direct or inverse variation? Well, what we're going to do is check the ratio y over x in all of the ordered pairs. And if it's always the same, if I divide whatever my y is by my x and I always get the same number, then it means I have a direct variation, right? Because right now we're looking at direct. But if I try that and I keep getting ever-changing numbers, then I'm going to check and see if it happens to be that x times y always gives me the same answer. If x times y always gives me the same answer when I'm looking at any ordered pairs, then it means that I have an inverse variation. Okay, so we'll be using tables in a moment to talk about this. All right, if I graph, remember of course that y equals kx here. So if I'm going to graph it, I know that I'm going through the origin because plus 0, my origin, right? So I'm going to go through the origin, and whatever my k is my slope. It is going to be a straight line, yeah? So if it happens to be negative, it'll just be a negative slope. Okay, k is greater than 0, k is positive, it means I have an upward line, and k is less than 0 means k is negative, downward slope. All right, now the fancy new word that we are going to use is hyperbola. Hyperbola, and that's what happens when I have y equals k over x. So if you were to plug in y equals 3 over x, y equals 2 over x, y equals 1 over 4x, bunch of those things like that into Desmos, you're going to see you always get a hyperbola, okay? Not to be confused with parabola, which is one single curve. These are two different curves that have a line of axis in the middle where they are going away from that line. All right. So if my k value is positive, then I'm going to be in quadrants 1 and 3. But if my k value is negative, then I'm going to be in quadrants 2 and 4. Okay, kind of in the same way that I know if I have a positive slope, I'm going to be going uphill, and a negative slope, I'm going to be downhill. All right. So how do we solve for missing values? Well, we know that if we are using direct variation, we know that every single time we say y divided by x, we're going to get the same amount. So again, if I have a bunch of ordered pairs or a table, I can choose any y and its affiliated x and say y divided by x, and it has to equal the same ratio as any other y divided by its x. And on the other hand, if I'm talking inverse, my products will always be the same. Okay. Let's take a look and see if using the numbers and the tables and the graphs can help make sense of all this. Okay? Situation 1, we need to travel a total of 480 miles. Okay? Or you need to travel a total of 480 miles. You have decided to drive, and you want to know at what speed you have to travel, depending on how much time you have to make your trip. So we're going to fill out the table below to find the speed we must travel. All right. So in this case, I know that speed is going to be miles per hour, right? So if my number of miles is 480, because it is, right? 480 miles per hour in 10 hours. 480 miles in 10 hours is equal to 48 miles per hour, right? So if I go 48 miles per hour, it'll take me 10 hours to do my trip. Now, if I'm going to do this in 8 hours, I know I have to go 480 miles in 8 hours. I'm going to have to go faster, right? So I do that math. 48 divided by 8 is 6, and then I still have a 0, so I'm going to have 60 miles per hour, right? if I want to go 480 miles in 6 hours, 80 miles per hour, we're getting a little fast. Yeah? Okay. If I want to go 480 miles in 5 hours, I'm going to be going 96 miles per hour. So we're on a test track or something, I guess. And if I want to go 480 miles in 4 hours, I must be going 120 miles per hour. We're now on a rocket ship or something. Okay, 480 miles in 3 hours. We are now going 160 miles per hour. All right, so let's see what this means to us. So I'm going to think about this. Now, as my number of hours is decreasing, my speed is increasing, right? So when we were talking about whether it is direct or inverse, we said that if one is increasing while the other is decreasing, that's what we've got. We said it's an inverse relationship, right? This is inverse relation. Inverse variation, because as one is increasing, the other is decreasing. So as the number of hours decreases, miles per hour increases. Miles per hour would be speed. Let's go ahead and write that as speed instead of miles per hour, sorry. Speed increases. Okay, one's going up, one's going down, so I know it's an inverse variation. So that means when I graph it out, it should look like a parabola, not a straight, like a hyperbola, excuse me, not a straight line, right? So let's check and see if that's what we actually have happen. Okay, so I'm going to label in my speed, I'm going to label by 20, 40, 60, 80, 100. I'm going to pause while I fill this in. Okay, so I've at least made my table so that we can see that this is speed along here, and this is number of hours. Okay, so in 10 hours, I'm going to be going 48 miles per hour. 10 hours, here's 40, here's 60, in between would be 50, so it's about where that's going to be, right? In 8 hours, I'm going to be going 60. 8 hours is 60. In 6 hours, I'm going to be going 80. 6 hours is 80. 5 hours, I'm going to be 96. 5 goes almost to 100. 3 hours, I'm going to, did I miss something? Sorry, 4 hours, I'm going to go 120. 120. 3 hours, I'm going to be at 160. 3, I'm going to be at 160. Okay, and so I am making a hyperbola here. So, oops, I kind of rocked that off, but you can see that that is a variation that is not a straight line. That variation is going to be using the constant of variation 480 miles is what we were thinking about. So every single time I was figuring out time in hours, I said I'm going to take 480 miles divided by my speed, right? That is literally what I did when I filled out. So 480 divided by speed. So you can see that if this was y and x, I would say y equals 480 over x. That is inverse variation. All right. And right here is where I should have written that, y equals 480 over x. Okay, so we made a hyperbola, so we know it's inverse, and also one is increasing and one is decreasing, so we know it's inverse. All right, let's look at situation 2. Actually, I want to back up one more time and just make, we are decreasing here the whole time, right? And we are 48, 60, 80, 96. We are increasing. Okay? All right. Number 2, situation number 2. For your trip, you want to track your gas usage. So your gas mileage is 30 miles per gallon. 30 miles per gallon. So you're going to make a table that tracks the gallons of gas used and the distance traveled. Gallons of gas, distance traveled. Okay, so gas mileage is 30 miles per gallon. So if I have 1 gallon, then I can go 1 times 30. I can go 30 miles, right? If I have 2 gallons, I can go 2 times 30. That's 60. 3 gallons is 90. 4 gallons is 120. 5 gallons is 5 times 30, there you go, 150, and 6 gallons, 6 times 30 is 180. As I am increasing here, 1 goes to 2, I'm also increasing here. So probably I'm going to have a direct variation, right? Now I just need to make sure that my ratio is always the same, right? So in this case, my constant of variation is 30. That is the number that gets multiplied times everything here. And I know that I start with y. Whatever my y is, y equals 30 times x, right? So if I know x is 1, 1 times 30 is 30. I know y is 30. Y equals 30 times x. Okay, that is direct, and let's go ahead and graph this. Okay, and again, I'm going to pause and not make you watch me fill out the graph. Okay, I've at least labeled my graph now, and so I'm going to plot these points. So at 130, I have a point, at 260, at 390, at 4, 120, and you can see I'm making a straight line, right? At 5, 150, 5, 150, and at 6, 180. 6, 180. So you can see that that is a straight line. Oops, I'm dropping stuff. So you could predict after you were going 15 gallons, you could predict how many miles you could go. All right, so this is a direct variation, because as one increases, the other also increases. So as the number of gallons of gas we have, number of gallons increases, the number of miles increases. Oops. As gallons increases, miles increases. All right, so now we're going to look at this in a slightly different way as well. Okay, so we are going to have some tables to look at, and we're going to actually just do algebra to try to figure out instead of drawing a graph. So here we go. Okay, I know that if I'm increasing on both sides, then it's possibly going to be a direct variation with a specific constant. But if I'm increasing on one side and decreasing, I might have an inverse variation. Okay, so I am increasing, right? Increasing. And here, 21, I'm decreasing. So I'm assuming that if we have a constant relationship going on here, it's going to be inverse. So let's take a look and actually do some math numbers. Okay, remember if it's, so I think it's inverse, right? And with inverse, we know that the product of x and y always has to be the same. So 3 times 21 is 63, last time I checked. 7 times 9 is 63. 9 times 7 is 63. So the products are always the same. Products are always constant, and my product is, in fact, 63. Okay, so I know that I would write this equation. Remember, k is my constant, the thing that I am always doing. Y equals 63 over x. That would be the equation I'm writing. Okay, and remember that we can get that from x times y equals 63, yeah, because we divide each side by x. Okay, example B, let's take a look. I'm increasing. I bet this one's direct, so I'm going to go ahead and take a wild guess and say it's direct. This means then that anytime I say y, oops, excuse me, there you can't see it. Anytime I say y over x, it's going to be a constant. That's my ratio. So let's try y over x. Okay, every single time y over x is going to be 2 over 6, which is 1/3. I have 5 over 15, which is 1/3. And I have 7 over 21, which is 1/3. So sure enough, that fits my direct variation. And I'm thinking that that constant of variation must be 1/3. Okay, so I know that my equation is going to be y equals 1/3 times x. We can also say that that means y equals x over 3 if we want to, but we like this format better. Okay. Okay, example C, let's figure it out. 4 to 8 to 12, we are increasing. 6 to 10 to 14, we are increasing. We're increasing both times. So if I'm going to guess, I'm going to say maybe it's direct, but it's only direct if my constant is exactly the same. Okay, so we already said that with a direct variation, our k is always going to be y over x. So we're just going to try y over x every single time here. Okay, so y over x, I have 6 over 4, which is 3 over 2. Now I have y over x is 10 over 8, which is 5 over 4. Uh-oh, not the same. 14 over 12, that's 7 over 6. So this is not constant. It's not constant, it's not the same. So what it means is, no, it's not direct. We definitely know it's not inverse because it's not one going up and one going down. So we're going to say neither direct nor inverse. Okay, because I didn't have anything constant. I had no constant variation. So nothing existed here, none, right? So I can't write an equation. Okay, all right. So let's take a look. We got some graphs. Now we know when we were talking about y equals kx. Do I need to flip this over? Let me come back over here. Sorry, back to situation 2. We have y equals kx, y equals 30x. You can't see that because it's out of the range. Sorry, y equals 30x. Notice that there is no b value. There is no y-intercept. We are crossing at 0. That is going to be the case all the time with this direct variation. Okay, we're going to go through the origin. So here we go. If I have a straight line that's going through the origin, that's going to be direct. There is a way for me to write an equation y equals kx, right? Okay, there is some slope that I can define. In this case, y equals 2x. If I figure it out, I go up 2 over 1, up 2 over 1. This guy is not going through the origin, so we're going to say it's neither. There is a relationship. There's a linear relationship. It's just not a direct variation because it doesn't go through the origin. This is half of a hyperbola, right? So it is probably going to be inverse, which means I know y equals some number k over x, and I would have to figure that out. So I'm going to just pick 2 points that I'm willing to work with. I'm going to pick this point 1, 8, and I'm going to pick another point about 2, 4. 2 points that I'm willing to work with because those are pretty obviously right on that grid. Okay, and so I'm going to find that 1 times 8 equals 8, yeah, because we said with an inverse variation, k equals yx, yeah? Because if I multiply x times each side. Okay, so I'm going to x times y or y times x. Here, 2 times 4 or 4 times 2 is also equal to 8. That's my constant. Any ordered pair I choose, if I multiply the x and the y together, the product is going to be 8. So I can write this as y equals 8 over x. As long as I know it's an inverse relationship and I can figure out any of the ordered pairs, I can figure out what that k value is. Okay, so you're going to take some time finding missing values. So you're just going to have to remember if it varies inversely, y equals k over x. And if it varies directly, y equals k times x. So let's take a look. We know in this case y varies inversely. Y varies inversely. So I know y equals k over x. So I can find k by multiplying x times y. K equals x times y. So the product is always going to be the same. Okay, so constant product. Okay, so if I have xy is 12, 2, that product, 12 times 2, equals 24. If I have x is 4, and I need my y, I know 4 times y has to equal what? 24, because it has to be a constant product. Okay, divide each side by 4, I know y has to equal 6. Okay, k is 24. And I know y equals k over x. Okay, so y equals 24 over x. And I have been told that y is 6, so 6 equals 24 over x, and so x has to equal 4, and that brought me back. I probably should have done that with the x, sorry, 24 divided by 4, which is what was given to us. And then we've solved 6 is our answer. Sorry, I did that a little backwards. All right, that's when we vary inversely. When we vary inversely, we have a constant product. But if we vary directly, we're going to have a constant ratio, okay? So varying directly, I know y equals kx. So I'm going to make that ratio, I know y over x equals k. Constant ratio. Okay, every time we have a y, we can divide it by x, and we're going to get our k. So I have x and y here. I know then that y over x equals 4 over 16, which I can simplify to 1/4. Okay, my ratio has to be 1/4. So if I know that my ratio has to be 1/4, and that is y over x, I know 12 over x equals 1 over 4, and I can figure out my missing x value, right? Right? So I know cross multiply, I'm going to get 48 equals 1x. So x equals 48. Okay, and we found y equals 6 up there. Okay, density and volume. There it is. Sorry, density and volume are inversely proportional. Inverse means we're going to have a y equals k over x situation. Okay, so when the density of a substance is equal to 2.5 grams per centimeter cubed, the volume is 3.7 centimeters cubed. What is the density of a substance if its volume is 3 centimeters cubed? So we know that we are going to have k be exactly the same. Y over x equals k, right? And so I can say that y over x, forgive me, again, sorry, if I want to get k all by itself, basic math apparently is challenging me today. If I know y equals k over x because it is varying inversely, then I multiply each side by x. So I know x times y equals k. That's our constant, right? So I know that if I have the density is 2.5, and the volume is 3.75, then I know 2.5 times 3.75 is going to be my k value. So 2.5 times 3.75 is going to be 9.375. That's k. That is my k value. Okay, so I know that I can figure out if I have a substance that is 3 centimeters cubed, I know that I can figure out density equals, nope, did that wrong, sorry. Density times 3 centimeters cubed is going to also equal that 9.375, right? So I'm going to divide each side by 3, and I get density equals 9.375 divided by 3 is 3.125. Grams per centimeter cubed. Okay, so if you actually wrote this out with your units, you would be multiplying 2.5 from the original problem, grams per centimeter cubed, times 3.75 centimeters cubed. Do you see this? Your centimeters cubed cancel, one divided by the other, and so you're just left with 9.375 grams. Okay, so you can actually make sure that your units are working out properly. Here I have some density times 3 centimeters cubed. So I'm trying to figure out what is my density there. So my unit should cancel out properly there as well. Okay, so if I'm looking for 3 centimeter cubed is my amount, and I'm trying to figure out my density. Okay, I'm not sure, I can't. Talked about that very clearly. Sorry. Getting to be a long video. Here we go. Hours worked and money earned are directly proportional. If they are directly proportional, I know I have y equals k times x. After 9 hours, Nancy earned $77.85. So how much will she earn after 30 hours? I'm going to set this up like a proportion, okay? So I'm going to go hours to money equals hours to money. So I'm going, because it's a direct relationship, right? So I'm going to say, also here's how I'm doing this. I'm dividing each side by x. I have y over x equals k. The k has to be the same for each of those. So k has to equal y over x. So it's going to be 77.85 over 9. But it also has to equal some other amount of money over 30. Okay, money over hours, money over hours, money over hours. Okay, so now we're going to cross multiply, and so we're going to get 9x equals 30 times 77.85, which is 2335.5. Okay, and then I'm going to divide each side by 9, so x equals 259.50. So that's how much she's going to earn in 30 hours. Okay, that's not the only way to do it, but probably that's the most efficient way to do it. All right, here we go. XY equals 18. So I know the product is always the same. Product is same. And I also know that I can write this as y equals 18 over x. Okay, so 18 over x, I know it's going to be an inverse. Right? This is neither, right? Because when I set that equal to y, I'm going to end up with y equals 1/3 x minus 5, right? So when I do that, it's neither, because I do not go through the origin. This guy, y over 2 equals x, if I find that that is y equals 2x, I can see that I have y equals 2x, and so I have a constant and direct variation. Right? Or I'm going to have a constant ratio. My k value 2 equals y over x. Okay, constant ratio. All right, so x plus y equals 0. This is the same as y equals negative x. And so k equals -1. I know that's direct, right? Over here, I'm going to check and I'm going to see if my products are the same or if my ratios are the same. So -6 times 8, I'm trying products first just to check. I have -48, -48, -48, -48. So the products are always the same. If products are the same, then I know it's inverse. Okay, and over here, I'm going to try products are the same. If the products are the same, I get products. I get 6, 24. No, totally not. It's not products are the same. How about ratios? 2 over 3, 4 over 6, same as 2 over 3, 8 over 12, yep, and 12 over 18. Absolutely an inverse relationship because the ratio is, absolutely a direct relationship because that ratio is the same. Okay, and you could always do a quick graph of that to make sure that with the direct, you're going to get a straight line through the origin, and with inverse, you're going to get those hyperbole looking things. So, great. Thanks for watching.